We're going to look at placing rational numbers on a number line using estimating with square roots and perfect squares. So the first thing that we want to do is get this table filled in. Square roots, we're going to use all the whole numbers starting with 1 up to 20. So 1, 2, 3, 4, 5, 6. And then we're going to jump over 16, 17, 18, 19 and jump right to 20. So go ahead and fill that in on your paper. So those are what we call square roots of the perfect squares, which we're going to put along the bottom. So the perfect squares are these whole numbers times themselves. So 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25, 6 times 6 is 36, and so on. So we'll go ahead and fill these in, multiplying each whole number by itself. Okay, and you can use that as a little cheat sheet there as we answer the questions down below. So on 1 through 4 down here says estimating radicals without using a calculator to determine which two integers each of the following radicals below falls between. So square root of 50. So we look at our perfect squares up here and we'll notice that 50 falls between the 49 and the 64. So we're going to write square root of 49, which is 7, and the square root of 64, which is 8. So if we had to estimate what the square root of 50 is to the nearest whole number, we know that it would be 7 because 50 is closer to 49 than it is to 64. Now we look at square root of 30, or 130, and if we look for what it's between, we see it's between 121 and 144. So square root of 121, which is 11, and the square root of 144, which is 12, and 130, which one is it closer to? It's closer to 121. So if we had to round the square root of 130, we would say it's about 11. Square root of 18, so same thing. Find what it's between. It's between the 16 and the 25. So we would say square root of 16, which is 4, and the square root of 25, which is 5, and 18 is closer to 16 than it is to 25. So if we had to estimate what the square root of 18 was to the nearest whole number, we would say 4. 75, it is between 64 and 81. So we say the square root of 64, which is 8, and the square root of 81, which is 9. So we know it's going to be between 8 and 9, and 75 is closer to 81 than it is to 64, so 9 is our answer. Okay, so we can use that little cheat sheet there to help us out as we are answering all of these questions. Part 2 here, now it says to use your estimation skills to graph these square roots on the number line. So we're going to do the same thing up above. Square root of 17 is between the square root of 16, which is 4, and the square root of 25, which is 5. And then it is much closer to 16 than it is to 25, and we know it's going to be between the 4 and the 5, so we go down to our number line between the 4 and the 5, and we know it's closer to the 4 than the 5, and then above that dot we put square root of 17. We're graphing the square root of 17 on the number line. So by using our estimation skills, knowing that it's going to fall between 4 and 5, and it's going to be closer to the 4 because 17 is closer to 16 than it is to 25, we know the dot should be just past the 4, between the 4 and the 5. We do the same thing with number 2. Square root of 4 equals 2, and the square root of 9 equals 3. So we know that the square root of 7 is in between 2 and 3. And it's closer to 3 because 7 is closer to 9. So we go down to the number line and closer to the 3. We put a dot and we write square root of 7. 28, perfect square below it is 25, which is 5. And the perfect square above 28 is 36. And the square root of 36 is 6. So we know the square root of 28 is between 5 and 6. And it's going to be a little bit closer to the 5. So just past the 5, we put a dot and square root of 28 above there. Now, if you notice on number 4 and 5, now we've got negative square root. So that negative sign there, negative square root of 2, just simply means find the square root of 2 and multiply that times negative 1. Okay, so for instance, if we had negative square root of 81, we would be doing negative 1 times the square root of 81. So negative 1 times 9, square root of 81 is 9. Negative 1 times 9 would give you negative 9. So the negative sign in front of the radical sign just means find the negative square root of that number. That's all that means. So same deal, negative square root of 1, which is negative 1, negative square root of 4, which is negative 2. So we know the negative square root of 2 is between negative 1 and negative 2, and 2 is closer to 1 than it is to 4, so the square root is going to be a little closer to negative 1. So our dot should be, again, you see it's in between negative 1 and negative 2, and then we label it negative square root of 2. You can go ahead and try number 5 on your own. If you want to hit pause on this and try number 5, and then see if you get it right. Number 5, negative square root of 16 is the perfect square below 18. That's actually greater than. And negative square root of 25 equals negative 5. So we know our answer should be in between negative 4 and negative 5. And 16 is closer to 18, so it should be, or 18 is closer to 16 than it is to 25, so our answer should be closer to the negative 4. So our dots should be right there, and above it, negative square root of 18. And we just repeat it on the back. We have the same thing. So square root of 1 is 1. Square root of 4 equals 2. And we graph that, and 3 is closer to the 4, so our dot should be closer to the 2. Dot in there, square root of 3. Square root of 9 equals 3. Square root of 16 equals 4. So again, you're finding the perfect square smaller than 10 and the perfect square bigger than 10. And you use your cheat sheet to find out where those are. So we know our dot should be between the 3 and the 4 and closer to the 3. So you put your dot there and square root of 10. Square root of 25 equals 5. Square root of 36 equals 6, and much closer to the 5. So just past the 5 is the square root of 26. Now I got the negatives again. Negative square root of 4 equals negative 2. Negative square root of 9 equals negative 3. So in between negative 2 and negative 3, and it should be closer to the negative 2. Again, because the 5 is closer to the 4 than it is the 9. And then negative square root of 5. Negative square root of 14 is going to be in between the negative square root of 9, which is negative 3, and the negative square root of 16, which is negative 4. So our dot should be between the negative 3 and the negative 4, and it should be closer to the negative 4. So right in there should be our dot, negative square root of 14. So that's all there is to graphing these rational numbers on a number line, estimating their square roots by using perfect squares.